The intake air temperature sensor, or IAT sensor, measures the temperature of the air entering your engine. This crucial data is sent to the engine control unit, or ECU, which uses it to optimize the air-fuel mixture for efficient combustion. A faulty IAT sensor sends inaccurate temperature readings to the ECU, which can lead to various performance issues in the engine. The sensor is typically a thermistor, a type of resistor that changes with temperature, detecting air temperatures ranging from -40 degrees Celsius to 120 degrees Celsius. A common symptom of a bad intake air temperature sensor is the check engine light illuminating on your dashboard. This happens because the ECU detects incorrect temperature readings. Rough idling is another sign. The engine may shake or vibrate at idle due to improper air-fuel mixture from inaccurate temperature data. You might notice reduced acceleration. The vehicle feels sluggish when accelerating because the ECU can't optimize timing properly. Decreased fuel efficiency is a major symptom, with potential drops up to 20%. Watch as the efficiency decreases due to the faulty sensor. Stalling can occur, especially at low speeds or when stopping, as the engine struggles with the wrong air-fuel ratio. Increased emissions may result from poor combustion, potentially causing your vehicle to fail emissions tests. In some cases, it can trigger limp mode, limiting engine power, or cause failed emissions tests. These symptoms arise because the ECU defaults to generic settings when it receives incorrect temperature data from the faulty sensor. IAT sensors can fail due to several common causes. Understanding these helps in prevention and diagnosis. The first major cause is simply age and wear. IAT sensors have a typical lifespan of 100,000 to 150,000 miles. As they age, the thermistor inside degrades, causing inaccurate temperature readings. Corrosion is another common cause. Moisture, road salt, or environmental exposure can corrode the wiring harness and connectors. Additionally, physical damage during engine maintenance or accidents can break the connections. Contamination from oil leaks or carbon buildup is frequent, particularly in turbocharged engines. This deposits can coat the sensor, preventing it from accurately measuring intake air temperature. Extreme heat can accelerate wear on the IAT sensor. In hot climates or high-performance applications, the sensor degrades faster than under normal conditions, requiring earlier replacement. In some cases, the ECU itself may malfunction. This can lead to incorrect processing of the IAT sensor signals, causing symptoms that appear to be sensor failure when the issue is with the control unit. A faulty IAT sensor significantly impacts vehicle performance by causing the ECU to rely on incorrect air temperature data. This leads to improper air-fuel mixtures, as the ECU defaults to generic settings instead of optimizing for actual conditions. Drivers experience poor throttle response and sluggish acceleration due to the engine not receiving the right fuel delivery. Higher engine wear occurs from suboptimal combustion, putting extra stress on internal components. This can also damage the catalytic converter, as unburned fuel increases emissions and converter workload. In turbocharged engines, faulty readings can mimic boost leaks, causing the system to underperform. This results in a noticeable 10 to 30% reduction in engine power output. Overall, inaccurate IAT readings cause inefficient combustion and significantly decreased vehicle performance. In 2024, Ford issued a major recall affecting 500,000 F-150 pickup trucks due to faulty intake air temperature sensors. These sensors were generating false P0113 diagnostic codes, indicating high input voltage when the actual readings were normal. The faulty sensors led to owners experiencing significant fuel economy losses of 15 to 20%, as the engine control unit couldn't properly optimize the air-fuel mixture. Ford addressed the issue through a combination of software updates to the engine control unit and physical replacement of the defective sensors. The repair costs ranged from $200 to $400 per vehicle. Automotive engineers recommend proactive IAT sensor checks during oil changes, as failures often coincide with other intake issues. While sensors are relatively inexpensive, diagnostic labor can add up. Regular inspection can prevent more significant engine problems. With the rapid rise of electric vehicles, intake air temperature sensors are becoming less central to automotive systems. By 2025, EVs already account for over 20% of U.S. vehicle sales, shifting focus away from traditional internal combustion engine components like IAT sensors. Predictive maintenance using artificial intelligence is emerging as a key technology for IAT sensors in hybrid vehicles. AI algorithms analyze telematics data to forecast sensor degradation for preventive maintenance and over-the-air recalibrations. This reduces misdiagnoses by up to 50%, according to expert predictions. In pure electric vehicles, intake air temperature sensors are completely obsolete since there's no internal combustion engine. Instead, trends strongly favor battery thermal management sensors that monitor and control battery temperature. By 2030, internal combustion engine vehicles may constitute only 30% of the market, making IAT expertise increasingly niche. Now let's examine the key statistics and data on IAT sensor issues. According to 2024 NHTSA data, IAT-related failures account for 5 to 7% of check engine light triggers in ICE vehicles. The average lifespan of an IAT sensor is 100,000 to 150,000 miles. A 2025 survey found that 18% of engine performance complaints stem from IAT issues, with failure rates increasing in urban driving due to pollution. These statistics highlight the importance of regular IAT sensor checks for optimal vehicle performance.